some data cables. We have some 4 AWG wires with ring terminals and the fancy Amphenol connectors, a manual, a cable with a L14-30. The other side looks like it plugs into the chargeverter, some screws, 2 little mounting brackets, the EG4 CHARGEVERTER. Don't mind my stench. Don't mind my stench. I've been outside cutting grass all morning because literally for the past week it's been raining. And again tonight we're supposed to get some nasty storms, possibly some tornado weather. I don't know if you're familiar with my videos lately, but we've been having a lot of tornadoes here in Nebraska the last month or two. Anyway, later on today we're supposed to be getting some more thunderstorms with some damaging winds and possibly some hail. We literally haven't had sun in like a week. And I ordered the CHARGEVERTER so I could get all the cobwebs out of my generator from the last power outage. Basically, I'm trying to be prepared for the next power outage. So if you're not familiar with a CHARGEVERTER, don't worry, I'm not either because this is my first one. And guess what? I bought this with my own money. They didn't send it to me. Can you believe it? I still buy things? I do, occasionally. Anyway, I've gathered what this thing is it's basically the charger out of an inverter. All right, so you can hook it up to 120 or 240 volts through this plug right here, and then this side spits out 48 volts up to 100 amps. So if you're doing 240, you can get up to 100 amps. If you're only doing 120 volts, you can get up to 50 amps. So that's what we're going to be messing with today. And I also bought some other little adapters that I can kind of put together. So I got another L14-30 there. And then I got 2 more, so basically I can, you know, make it nice and easy. Because before I just had some wires ran in the house, which they're still over there dangling. We're basically just going to attach all of these so it'll be a quick disconnect. The other things that came with it, those did not come with it. This is the L14-30 plug on this side, and then this side is a quick disconnect which goes right here. It also came with some 4 AWG, I don't think these are technically silicone wire. They're close, but they're not quite. 4 AWG wire with ring terminals on one side and then the fancy Amphenol connectors on the other. So that'll be nice because it's quick disconnect. Came with a manual and some other data cables in here. It looks like we have dry contacts, maybe something for upgrading firmware later on, and apparently this one will also communicate with batteries for state of charge, stuff like that. I don't know if we'll get to that, but we might. And then the 2 little mounting brackets and screws so you can mount it to a wall wherever you want. I'm not going to be doing that today. We're just going to hook it up and try it out. Alrighty, here's the close-up. It says EG4. Looks like we have an escape, up, down, and enter button, a power LED, a charge LED, a 125 amp circuit breaker right there. It says EG4 electronics, CHARGEVERTER 5kW. This side's going to have all the specifications. On the back side is going to be your battery terminals, and then we have our dry contacts and RS-45 communication port right there. And this side has got the side for the L14-30 plug, quick disconnect right there. And that's basically it in a nutshell. You know as much as I do. All right, I don't even think I'm going to read the directions right now. Basically what I need to do real quick before it starts storming and raining is I need to make up a couple connections right here. So I need one of these inside the house so I can plug this end in here. Then I need this one on the generator. Okay, well, I guess I do need to get the manual out because inside of here, there's a little tiny wire diagram that shows you all the wires that are used, and it also shows you some other common plugs that you could use to wire this up. So we're going to be using the L14-30 right over here. So all we need is an L1, L2, and ground. Neutral is not used, which is good because I didn't run a neutral from my generator. Okay, so we're going to wire up some stuff real quick. We're going to get this connected and charge some batteries. All right, so this is a 5kw CHARGEVERTER. My generator is also a 5K. However, it'll do like 6 or 6.5K, which is good. I don't need 6 AWG coming off the generator, but that's all I have in small pieces right now. All right, let's get this wired up real quick. Oh, I don't even know if I can fit 6 AWG in here.
A few moments later.
All right, I only had some red 8 AWG wire. We'll do about 30 inches. This is going to be coming off of the generator. And we will just mark it with green and black tape. Does that go in far enough? Yes. Hopefully I don't break it. Mark this for green, even though I'm going to be the only one using it. If you're not familiar with the back of these, there's a letter for each one. You have G for green, Y for red, W for white, and then X for black. X and Y can be either one, red or black, since it's 240 volts, and it doesn't matter. It really only matters when you're doing hybrid inverters and stuff like that. Boom, there we go. We got one pigtail made for the generator, and then the other two we got right here are basically going to be an extension cable from the generator to the CHARGEVERTER. And earlier in the video, I said my generator wires are still dangling over here. They're not dangling, they're kind of shoved up there into the top, right up here. So these I had run for my grow watt, just so I could power everything from that during the last backup. And since then, obviously, some things have changed. We installed a new inverter and new batteries. Anyway, we need to hook up one of the L14-30 plugs right here, because this is going to be one end of the extension cable. The other end is outside in the garage. We'll squeeze all these together, shove them through here. All the wires. All right, blue is my ground, because that's the only color I had at the time. Get that in here. The next wire with the black tape, that's going to be L1. The next one's going to be open because that was the neutral. I didn't run a neutral, I just ran the 220. So this one, the red wire, is going to be my L2, and that's going to go directly across from L1. Boom, got one end of the extension cord done. All right, so I just finished up a video on these Ethos batteries right here, and there's no like open ports or anything like that. The only open port actually would be inside of here. We could probably run the CHARGEVERTER output up to these two terminals right here, since that's basically a battery connection. However, we're not going to be doing that. We are going to be connecting up more power, and I'm gonna call this the Tower of
Power of... No, with a Tower of Power, jeez.
All right, Andy, sorry, you already took that name, Power of Tower or Tower of Power. I won't use that one. I'm just gonna call it the Roly Power. How about that? All right, so we're gonna hook up these batteries in parallel with the Ethos batteries right here, and then we're just gonna hook the CHARGEVERTER right up to these, since we have all these extra terminals. I have all of these cables right here. None of these are specifically made up for this project or this whatever we're doing here. These are just some random cables that I have, and that's what we're going to hook up to these batteries, and then up through, right up into the elbow right here. We'll go up through the little conduit, and then we'll connect up to the inverter right up here. Okay, so these CHARGEVERTER cables, I don't think I mentioned it earlier, but they are longer or taller than me, so they're probably around 6 feet long, okay? I'm gonna need these ones as well. All right, here we go. So the center battery right here is gonna be basically where the CHARGEVERTER connects, and then the two empty terminals right here are gonna go up to the inverter. I'm gonna pull off the bottom of that elbow. We're gonna go up through there. Anyway, we go from this battery right here, and then we parallel down to this one, And then from this one, we parallel up to the top one. So we've got two 230 amp hour batteries, and then one 100 amp hour battery right up there. I guess what I could do is throw on some communication ports real quick. I can just plug them in. So go B to B. Okay, so communication from this battery down to this battery, and then from this battery up to the top battery. And then we might run the RS485A up to the inverter, just in case we get more amps from the weather outside. With the Ethos batteries right here, 3 of these in parallel will only let me charge up to 150 amps. However, if I have these connected through the communication, then I can go up to like 500 amps, even though I don't have 500 amps from the sun. All right, next thing I'm gonna do is take off that bottom cover right there, so I can run my battery cables up through here. All of these are turned off, by the way. Okay, get all these danglies out of the way, so it takes up less space. Like right here. Lock it down. Now, we need to run our positives and negatives up through here. Positive. All right, we can run our positive up to this bus bar up here, and we can tighten that one down. Must be getting some solar coming in. And then our negative up to the negative, right here. All right, my battery state of charge right now is 76 up here. Let me check this one down here. I'm just gonna go ahead and turn the BMS switches on. All right, these are 50% state of charge, so there's a 25% difference. I think I'm gonna flip the switch anyway. We could actually see the amp draw. All right, here we go. Here's the main battery. It's 120 amps. Here goes the second battery. 140. Here goes the third battery. 140, 112, 120, 130, 120. These are some pretty fat cables over here though too. If I can check the other ones. What's going in between each battery. That one's only got 15. That's got 50. All right, so up here we're still showing 77% state of charge. I would imagine this will go down, but maybe it'll stay the same. I'm not sure. We're actually recharging at 6,500 watts, so that's nice. Still doing 100 down here. Oh, you know what we could try while we're here? I wonder if I could get this around one of those Ethos batteries. We can. So that's showing 25 amps right there. All right, so now we have the tower of power, the roly-poly power, or whatever I called it earlier, connected up to the Ethos battery right here. And a total of those combined, I think, is around 44 kilowatt hour. So previously, I was just using that for a couple of days. All right, it's that time of the year again, and I don't want to do this, but I'm gonna need it. And of course I had to turn on the air conditioning, which just drains that like immediately. So we're gonna hook up this one. I should get a little bit more runtime. Hopefully I can get through the whole night with air conditioning. That would be fan-freaking-tastic. Anyway, what I came over here to do originally was to hook up that L14-30 to my generator extension cord right there. We'll go outside and hook up the other end, and then we'll start the generator, let it warm up, and then we'll come in and hook up the chargeverter to these wires right here. Here's the weather so far. It's still pretty bright out, so we're making some solar. But if you look over in that distance over there, it's definitely darker out that way. Okay, so what we need to do is I need to grab my wires that are right back there. These are my generator wires, so I can easily get them. Unroll this out here. Yes, I know a real generator wire would be nice, but I don't have one of those. Okay. Black is X, W still open, Y for red, blue for ground. Alrighty, there we go. Now we have our generator extension wire complete. Next thing we need to do is add this onto the generator, which is still right there in my driveway. Yeah, it's been there for a year. I still need to move it. Go in here. Please no wasp. Thank you. There's actually a little tiny hole on this side that I can run my wires through. So I can have my little pigtail sticking out off the side, which will be very, very safe. Okay, so, all right, wiring up this really old generator is super easy. Obviously you can see L1, L2, L3 if you're doing 3-phase, and then here's your neutral right here. For mine, I only need to hook up L1 and L3 so I can get my 240 volts. It's a terrible place to put a wrench. I might have to rebond this. Here's my bond right here. Usually if this is hooked up to my inverter, like I've used it before, I unbond it because it's actually bonded to my system, which is bonded, you know, through the main panel and then outside to the ground rod. Since I'll be running this as a standalone, I'll probably have to put the bond back on. So anyway, we'll put this right here. Use the big old wrench. That gives you all sorts of room. This one has L2. I literally haven't started this since the last storm. Oh, there is a wasp nest. There's a wasp nest in here. See him right there. You see him? Ugh, die. Okay, anyway, where were we? Last one is L1. It's just like when you're working on like exhaust on a car and you can't get to the exhaust bolt and you can only do a quarter turn at a time. That's what this is like. Okay. Yeah, I'm gonna grab something so I can rebond this real quick. You're not a 10?
Nope.
What are you? 12?
Nope.
11? All right, 11 works. Oh, that one's spinning behind it. Why would I ever need to rebond it? Well, go ahead and buy a chargeverter. Then you'll have to rebond it. We're almost there to see if we can even start it. I probably should have checked that first. Okay, we're rebonded now. Next thing we need to do is see if the generator will even start. Over to this side and see if there's any wasps over here. Please, no wasps. Okay, here's my battery switch right there. Go to normal. Then we open up this door. Pull that. Ooh. All right, here we go. Oh, nice. Oh, look at that. We got some new neighbors. Yeah. Okay, and I'll wait for this to warm up just a little bit, and then we'll be right back.
Moments later.
Temperature has come up. We're looking good. Close that. Light came on. Grab our extension cable here. Back inside, I want to check the voltage at the end of this plug real quick. We got 123.9 on that leg, 123 on that leg, 247.8 volts. So we are looking good. I am totally not ready for this video at all. This is all made up as I go. All right, that is plugged in. I'm gonna blow it up right now. I just plugged it in and now we're turned on. Obviously, since I've never used this, I'm not exactly sure what we do, but we got it turned on. Circuit breaker is turned off, but I'm going to hold down the enter button. Okay, so it's sitting on 54 volts. The state of charge stuff I'm not too worried about because I don't think I'm going to be doing any communication or anything like that. It's set for 10 amps, and the battery stop voltage is 54.4. So we're going to raise the voltages and the current. So voltage, we're going to go to 56.4. And I've got solar assist up here, and I'll just put that up on the screen. This is going to be kind of pointless because we're already at 85% state of charge, but we're going to do it anyway. I'm not familiar with the buttons quite yet. We're going to raise the current up to, we're going to start with 50 amps, and then we'll move it up to 100, just to try it out. All right, 50 amps, and then our stop voltage, we'll just do 56.4 also. All right, well, we're going to go ahead and flip the breaker right now. Oh, so I have the dryer on, and maybe the air conditioning might have kicked on too. All right, here we go. How do we get back to the main screen? There we go. Okay, we're charging 15 amps and slowly going up. And again, it's not going to show up on solar assist because this is hooked up directly to a battery, and it's, you know, it's just not going to show up on here, but that's okay. So we're starting at 85% state of charge. Time now is 2:15 p.m. Yeah, we'll just let this go up to 50 amps, and then we'll let it run for a little bit, and then we'll just boost it up to 100. So right now we've got 7,000 watts of solar coming in, and we're charging the battery at 2,000 watts. We have a 4,600 watt load. Boom, we're at 50 amps, and the fans just started to kick on. They're pretty low right now. All right, I'll let this run for, I don't know, a couple of minutes, and then we're just gonna go right up to 100. All right, well, it's only been a couple of minutes, and everything seems to be working fine. Obviously, you can see we're really got some loads going on the inverter. Still doing 50 amps over here, no problem. We are going to raise that up to 100 and try that. Boom. All right, so when I do that, this is going to reset. I've seen that on other people's videos, and then it's going to slowly go up.
Moments later.
All right, I don't know if we're going to get much higher than 93, and that's probably because we're already at 86% state of charge. It's kind of hard to say, but if you look at the sound meter, I'll shut up. Roughly 66 decibels sitting right here, and if I go about 3 feet away, it's roughly 58 to 59 decibels. Honestly, what this sounds like is, if you've ever heard a Bitcoin miner or something like that, or just a regular server power supply, something like that, that's exactly what it sounds like. All right, so what I need to do next is check the amps coming in on these wires right here. The way they do these military diesel generators, it's a 5 kW generator. However, the way they, I don't know, derate it, and it shows up on the gauge out there, if you go up to 100%, it's actually like 6,000 or 6,500 watts. And 80% is actually 5,000 watts. I'm pretty sure we're over the 5,000 watts right now with the 93 amps, so we're actually going to lower it down to the 5,000 watts on the generator. So if I just measure right here, we're doing 23.2. Should be the same on both wires. Yeah, 23.2. And if we do the math on that, 23.3 times 240, we are running 5,592 watts. So it's not real far over, but it's a little over. So what I'll do now is I'll go outside and I'll show you the gauge on the generator just to show you what's going on, and then I'm going to lower the amperage on the CHARGEVERTER. All right, so out here on the generator, if you look at the gauge, 100% is way over here. We're not at 100%, which is good, but we want to try to bring it down to this green line right here. So what I'm going to do now is go inside and lower it down to 88 amps. I think that's what I've kind of calculated it out, and we'll be right at the green line, which will show 80%, but it's technically 100% or 5,000 watts or close to that. All right, so back down in here, we're going to go down to the current, and we're going to adjust that to 88 and then hit enter. All right, we'll hit escape. That's going to go back down to 0. All right, and that's going to be 0 on the gauge outside on the generator. So now we're going to wait for the chargeverter to go back up to 88, which should be 100% on the generator. All right, well, I think that worked out pretty good. We're basically right on the money and right on that green line. Nice. All right, back inside, we're doing 88.8 amps. Battery voltage is 54.1 volts, and we're at 89% state of charge. We're actually doing pretty good solar, 6,900 watts. We're charging the battery at 2,900 watts, plus, you know, the 5,000 watts or 88 amps, whatever it is over here. So this is working out really good. And since we have so much coming in, you know what I could do? I could go to the EP Cube and start recharging that. We'll hit backup, submit. I should have this on screen, whatever, but I'm not going to. All right, now we're gonna start recharging the EP Cube any second. Load's going up. So the air conditioning is on at the moment as well. So now we're recharging the EP Cube and this system right over here. And that little spot from the grid should go away here in just a second. There we go. All right, now we're drawing from the battery, but we're still putting in from the chargeverter. So technically we're probably only charging at a little over 2,000 watts maybe, or 1,500. Ooh, look at that, 10.4 thousand watts. Yeah, sorry about all the fan noises now. Ooh, 11.2. So that is the EP Cube, my house, and the air conditioning right now. So now we're not charging the battery at all. Basically, it's coming from the generator and the solar and powering everything. That's crazy. Yeah, I guess it's a good test, right? Time now is 2:39 p.m., by the way. It's not going to show anything on here because this is also a hybrid inverter. It's got a little tiny solar array on it right now, so we're doing 980 watts, nothing much. So yeah, we're sucking down 5,000 watts for the EP Cube. Boom! All right, I don't actually remember when we started this test or when we connected up these batteries, but I was gonna check the percent state of charge real quick. All right, so this is at 77.5% state of charge, and this battery over here, we're communicating with that one. It's at 90% state of charge. So we're actually getting real close to being equal. I don't even think we've been running for that long. Maybe, what, 45 minutes? Half hour? No idea. Nice, still doing 11,273 watts on this inverter. All right, so one of your questions might actually be, why would anybody need a chargeverter? There's only a couple things that I could think of off the top of my head right now. And the first one is, at least for me, is obviously I test a lot of different batteries. Using a chargeverter, I can set up different loads for battery testing, etc., and stuff like that. The second one would be is obviously if you're off grid and you have a generator to back up your house or your whatever you're trying to back up. You know, why couldn't you just hook it up to your inverter like this one? This one does have a generator input port right over here. Why couldn't I just hook up my generator to that and then continue powering my house and charging my batteries that way? Well, you could. However, I have heard a few different things, at least with this inverter right here, is what I've read on the internet, and we all know we can trust everything we read on the internet, is some inverters just don't like generators whatsoever. Like this one right here, I've read that some people have problems hooking up generators because the voltage spike might be a little different, or the hertz might go out of range just a little bit, and the inverter will basically kick off the generator or kick off that circuit so you're not charging from the generator or powering your house from the generator anymore. So having a chargeverter hooked up directly to your batteries will allow you to continue running your house off of your batteries. However, since you're using the generator as a battery charger only, you're just charging your batteries only and you can continue powering your house. Which kind of brings me to my next one, is air conditioning. Generators typically don't like air conditioners either, because whenever those kick on, the initial inrush or surge current from those pulls so much freaking power that it usually kicks out the generator. All right, and then there's kind of a workaround for that, is installing a soft start on your air conditioning, which I did do. What that does is it basically lowers the inrush current, so you're able to start your air conditioning from a generator or from, let's say, a smaller sized inverter. If you're going to be trying to run your house off grid or in an emergency when the grid isn't there and you want to run your air conditioning, you're definitely going to want to install a soft start. The reason I'm going to say that is because I have a 4-ton air conditioning, and that thing took so much power. It was like 130 amps just to start it, all right? Whenever I installed the soft start, it brought it all the way down to like 20 or 30 amps. It's freaking crazy. So what I was going to say is, if you're trying to run your house off grid or in an emergency and you want to run your air conditioning from a battery setup or a generator, you know, you're going to want a soft start. But anyway, what I was getting at is you can still run your house, run your air conditioning all from the inverter, you know, hooked up to the batteries, and have your generator charge just the batteries alone. The other one that I can think of, depending on how your system is hooked up, for example, my system right now, it's kind of a partial home backup. So what that means is power comes in from the grid to this panel right here, and then from this panel, that's where I power my hybrid inverters, and then from the hybrid inverters, I power this panel right here, and technically this one right over here. So if the grid ever goes out, everything in this panel right here, which is like my stove, air conditioning, and dryer, like the big load type stuff that I don't technically really need to run in an outage, those are all in this panel, but everything on this panel and this panel right here will still be powered, which is like 90% of my home. So in a grid outage, if I had the generator connected up to the hybrid inverter, I'm still not able to power this panel right here. I would only still be able to power this panel and this panel, because it's a hybrid inverter and how I have it hooked up in the partial home backup way. I can't backfeed this at the exact same time. All right, and that's another positive for using a chargeverter. Those are the things that I could come up with right now.
A little longer than a few minutes later.
Alrighty, time now is 4:50 p.m. So we've been running for a little over 2.5 hours. And if you look at solar assist, I'll put that up on the screen. We are sitting at 95% state of charge. That's at least on those batteries, the Ethos batteries over there. We're not actually charging from solar or anything. We're purely charging from the chargeverter right now. Let me check the percent state of charge over here real quick, and we can see how close we actually are, since we started at 50% with these. Okay, these are at 91% state of charge. So we're actually really, really close for the Ethos and the server rack batteries being equal. And another really cool thing is I can switch over to the EP Cube. We're actually sitting at 91% state of charge, which is 15.21 kilowatt hour worth of battery storage right now. It's a little over 16 whenever it's fully charged. So we went from 15% state of charge up to 91%. Nice. All right, that's pretty much all I got over here. I'm gonna start shutting this stuff down, and then we'll reconvene over there. All right, so far the chargeverter has worked out fan-freaking-tastic. There was a few things I wanted to mention with the cables that it comes with. This one right here with the USB and the Ethernet end. This one is going to be for updating firmware, etc. The one with the yellow ends, this one's going to be for your battery communications. And then the other one, of course, like I mentioned at the beginning, this is for adding a generator for your contacts and stuff like that, which you could definitely do. You would want to use both of these, so you could turn on your generator based on a low percent state of charge, and then have it shut off at whatever percent state of charge you want. Now for the communication, as far as I know, I don't know much about communication, but I think in order for me to hook it up to these batteries over there, I think I have to get a different cable and swap the pins around. That's all I need to do. I think this one's technically for EG4 batteries, and probably other batteries that are very, very similar or use the same protocol, stuff like that. I think just for those specific batteries over there, this cable will not work. But that's okay. I could probably figure out some other cable to use. And there is one other thing I want to mention real quick whenever I was back at the electrical panel, and I might not have explained it clearly. or properly. I mean, there's obviously many different ways that you can hook up your system. The way I have mine, again, is a partial home backup. So I come in from the grid to my main electrical panel. From the electrical panel, I go over to the hybrid inverter, and then out of the hybrid inverter, I power the sub panel. The reason I have it like that is previously I had a grow watt inverter over here, and that didn't have any sort of, hybrid capabilities or backfeeding capabilities. And I wasn't too concerned with running the air conditioning, dryer, stove, stuff like that in a grid outage. So I basically installed it kind of the same. I went from my main electrical panel over to the grow watt, and then out of the grow watt I powered the sub panel. So whenever I hooked up this one, I basically just did it the exact same way. Maybe sometime in the future I could change it. I could come from the grid to the Lux Power inverter, and then from the Lux Power inverter to the main electrical panel, which would power my entire house, everything. That way whenever the grid does go out, I can still power everything. And then I got to back up again real quick for how I have mine powered. Since this is a hybrid inverter and I'm coming from my main electrical panel to power sub panels, I got the inverter in the middle. Since it's a hybrid inverter, it can backfeed my main panel unless the grid goes out. If the grid goes out, that connection disappears because it's kind of like island protection where you don't want to send power back out to the grid. It has that safety capability. So I can only power the sub panel, okay? Keep that in your mind. If I hook up a generator directly to the inverter, which you can do, you should be able to do that no problem. I haven't tested it yet, but I will here soon. If the grid goes down, I still can't backfeed my main panel. I can only feed the sub panel. So if I have a CHARGEVERTER, I guess in my situation it's kind of the same. I'm still powering my sub panel only. However, I can just send the full 1000 watts to charge the battery. That's what I'm coming up with. All right, well that's pretty much all I got. If anybody has any questions, comments, or concerns, or any other pros or cons for a CHARGEVERTER, let me know down in the comments section. If this video was helpful in any way, make sure you like that smash button on your way out, and I will see you. Since I've got two hybrid systems right now, I've got the EPQ back there and then this system right here. I'm using this one as my main system, and then that one's kind of like a backup system, but it's still on and doing its hybrid stuff. That one was actually down to 15 or 20% state of charge. I can actually recharge that one over there from this one over here and not pull anything from the grid, which is kind of cool, actually. I've tried this before a few months ago, not with the CHARGEVERTER, obviously, but I've tried this one being as the main, system, and then I tried recharging that one over there from this one. I don't know, it didn't really work. It still pulled from the grid, but right now it's pulling from this one, which is pretty awesome.